I am the CIO and Chief Marketing Officer here at Walsh College. I'm also a Walsh grad. So if you have any doubts about the power of a Walsh degree to get you someplace, here we are. All right. So tonight we are going to talk about a day in the life of an IT worker. We've got a pretty aggressive agenda and lots of different speakers to talk to. So you're not going to hear me talk too much at the beginning, but here's our agenda. We are going to talk about future demand and salary information for IT professionals. You're going to hear from a number of different professors here at the college about different IT careers and what you would actually experience in a day of a life of an IT person. Then we'll do some Q&A with the different faculty, the advisors, admissions and career staff here. And then we'll do some touring around the building here, and there's some refreshments at the end. Next slide. All right, what I want to do is start with kind of a couple of framing questions. And within the field of IT, there are many, many different careers. So whether you are somebody who is creative or somebody who is about protecting assets, people, organizations, or solving problems by using code and automating part of people's jobs, or looking at patterns in data to find solutions, creative solutions to business problems, or if you want to lead teams, we've got things here that can help you do those things and be successful in IT careers. Terry, if you want to go. Okay, so lots of different options here. Leading IT departments. This is what I do here. Whether you want to design websites, mobile applications, we do have coursework in that. Designing, building networks, all of these different things on the slide here. I don't want to read all of those things. You can read those things on your own. I don't want to do a dramatic reading. That would be boring, right? But we want you to bring your passion, your energy, your ideas to Walsh College because it makes the field better. It makes our programs better. And I can tell you, as a faculty member, interacting and teaching you all is an amazing experience that is so fun and so rewarding. Okay, so let's go to the next slide and talk about a couple of things. First, is an IT career a good idea? You know, there's been a lot of shifts in the world over the last couple of years. This little thing called COVID happened, right? And a lot of things changed, but what has not changed is the outlook for IT people. So we are going to continue to see aggressive growth in IT. We're going to see automation. We're going to see new software systems. And I'm going to tell you, cybersecurity, you're going to see in a couple of slides, huge opportunities there, okay? So we're going to be adding a lot of jobs to the economy by the year 2030. And down at the bottom here, there's some numbers that might be of interest to some of you who are newer to the profession. It's about double the average salary is the average salary of an IT worker these days, okay? When you talk about having a good life, having a good family, and meeting all of your goals and stuff in life, IT is a place to be. I would say it's the place to be, but some of the individuals from other careers might disagree with me, but I love IT, all right? So there is a lot of demand for IT managers. You can see that the job outlook, the growth rate is about 11%. Why is that? Because a lot of IT managers are terrible. So we got to train up new ones. People who know how to lead, people who know how to make decisions, people who know how to organize and coalesce around goals and make things happen, okay? We need good IT managers, and we have a great program for up-leveling those individuals. Now, I want you to pay attention up here where it says bachelor's degree, okay? You can be an IT manager with a bachelor's degree, but if you get a master's degree, this will take you beyond just the IT parts and help you with leadership, communication, finance, budgeting. These are the skills that you get in a master's degree and will make you a successful, very successful leader. This is why I went back to school. I can tell you, when I got my master's degree, it opened up all kinds of doors for me. So if you're thinking about leadership, you should be thinking about master's degree. All right. Let's go to the next slide. Security analysts. Very nice salary for that group. Look at that growth rate, 33%, much faster than average. Now, I want you to pay attention to that number because the next slide's got something that's very interesting that Professor Ferruzzi is going to talk about in a couple of minutes when he talks through his presentation, okay? 33% growth, lots of opportunity in there, bachelor's degree. We have one of the best cybersecurity training programs in, I know the state of Michigan, but regionally and in the country, okay? We have hands-on, we have capture the flag activities. It is very practical and it is modernized. We are constantly looking at our curriculum and making changes and adjustments to the changing evolving threat landscape. We want people to come out of here who are critical thinkers, who can solve problems and be of extreme value to their organizations, okay? So that's IT security. Now, if you look at network specialists, we see that growth is slower than average. Why is that? Does anybody have an idea why that might be? Like networks are everywhere. Why would this be slowing down? Any guesses?
I have one.
Well, there is virtual. Here's what's happening. A lot of the network specialists are cybersecurity specialists, okay? When you get into cybersecurity, you are getting a base foundation in a number of different things, but also you're gonna be kind of a jack of all trades, but you're gonna be specializing in security. So a lot of those jobs, it's not good enough to just be able to set up a network anymore. You have to do that securely, safely, and sustainably, all right? So with that, let's transition to the next slide. You can get some more information about cybersecurity degrees. There's a link right on that slide, but you will see something that is very, very consistent. Growth, opportunity, and all of that leads to a great and better life, okay? So now we're gonna hear from some of our professors. They have all worked in IT for a long time. And afterwards, you're gonna be able to ask them questions, okay? So with that, I'm gonna turn it over to Professor Richards, who I have known almost 20 years now.
Indeed. Indeed, you have, Tom. Thank you.
Switch to view. Okay, go ahead, Terry.
Can you hear me okay?
Yes, we can hear you.
You can hear me? Fine. All right. Well, welcome everybody. And whether or not you know exactly what niche in IT you want to be in or not, we have people tonight to talk about it, as Professor Petz just said. I'm going to talk about the project manager and a similar role, the systems analyst. If you like to lead, as Tom was just saying a moment ago, or you like to oversee projects, you want to get things done, and you've got organization skills, good communication skills, you solve problems, you don't go to other people to get them to solve them, you can do it. You watch details, you can delegate, you've got good analytical abilities. This might be the role for you. And why are these skills important? Well, because a project manager literally takes a simple project request like this. Sometimes it's a proposal or a business case, but usually it's a page or two. And they have to take that and meet with the stakeholders and the users and turn it into something like this from that request. And how do they do that? Well, through planning. Believe me, that's a huge part of it. They have to plan. There's a lot of iterative work in there. So when we do analysis and design work, we do an iteration, we look at it, maybe we fix it, maybe we improve it, maybe it gets tossed out and we do it again. And then we build, which is coding and design. The coding and design, we develop it. We could put some of it into production, release maybe a homepage of a new website and go back and continue to work. And that way people don't have to wait till the very end of the project to get the deliverables that they've asked for. And of course, the project manager doesn't work alone. There's network people on there, systems analysts, data designers, data modelers, programmers, cyber experts, and more. A typical day for a project manager, though, does depend where you are in the project. There's phases in a project. We start out by meeting with the stakeholders and the people who requested the changes and deciding exactly what they want. And once we've gotten that written down and approved, the project starts by planning. We begin to estimate, we schedule the tasks that have to be done. We create all sorts of diagrams and specifications, Then we get the programmers and the modelers involved, and they start using those analytical diagrams and specs to build the code. Now, the project manager works with the programmers, modelers, users to keep the project on track. They have to clear the path for them, solve the problem, keep the costs under, provide solutions. They have to do it all. They spend a lot of their day, probably most of their day, communicating. Project managers do, meeting and communicating, solving problems, meeting and communicating, and tracking things. Monitoring means that you are watching the software, which I'll show you in a moment, updating the stakeholders, watching the changes that are coming into the project. There are always changes, and making sure things get done. And finally, in the last phase of the project, the project manager oversees the implementation and then does a lessons learned meeting with the team to find out what went right and what went wrong. How can we learn from it? So really quickly, here's 3 documents that a project manager might create. This is called a work breakdown structure. The project request, the title is up at the top, and the project manager and her analyst or his analyst begin to iteratively break down what has to be delivered. So if this was a new e-commerce site, this might be the logon screen. This is the home page. These are the other pages, and then these are the deliverables for each of those. We need an about us link. We need a contact us link. We need our history and our map and the store hours, et cetera, et cetera. Once those deliverables are defined, we turn them into tasks and we put them into what order they have to be created. So you have to be able to have started the project, and there are things depending upon it to move forward. So we have to put this out in what we call a project network diagram or a PERT chart. And it only talks about in what order do we want these things to get done. The arrows indicate dependencies. We take all of that and we put it into something like MS Project, which is what this is right here. Project schedules on the left. The project schedule talks about, it starts to say who's going to do what, how many days do they have to do it in, and when do they need to be finished. There's dependencies in here. That's what these little arrows mean. The project manager enters this all in. The time card entry system will update this as programmers and others finish their work. They'll go up to the file tab, there will be a drop down that says run or execute, and it'll recalculate all this. And as a project manager, I used to do this every Monday morning, just to make sure we didn't have somebody going off into 2024 accidentally. Every one of the steps is important. Even things that you don't expect to happen, though, will happen. I was a seasoned project manager just very quickly. Luckily, we caught it before it went live, which is a testament to the power of testing. You cannot skimp on testing. We had physicians, I was working at a hospital, we had physicians who didn't want to log on to the PCs every time they walked up to them. They didn't want to take the time to put in their name and their password. So they asked, could we just give them a card, like you see here, that they swipe and it would log them in? Well, they wanted it to log them completely in with passwords too. We didn't allow that, but we did have it make sure that it could bring up the logon page, put their name in, and be sitting there waiting for their password. We did a phased implementation, or we did a pilot, maybe it was. We actually went to the hospital's main campus, went onto a nursing unit, and had a physician with his badge around his neck walking down through the nursing station, past all the PCs to get to one at the end where we wanted to do the testing. And we didn't expect this. As he was walking through, the nurses and the technicians and everybody else at the station were going, hey, I just got logged off. Who's Dr. Miller? Hey, I got logged off too. We didn't realize that the range, of course, was too broad. And we ended up having to go to a swipe system because we were just using the proximity. But if we hadn't tested that, if we hadn't gone on site and tested it, it could have been disastrous. So that's the type of thing that you have to really be careful doing when you are a project manager. You don't let anything get out of control. In summary, the IT projects are carried out by project teams led by a project manager to bring about the results that the stakeholders have asked for. And I'll take questions at the end. But next, we're going to have Professor Petz again talking about programming.
Oh yeah, I forgot to mention I also teach here. Right? I have a couple of hats that I wear. That is just one of them. But yeah, let's talk about programs. I'm actually a programmer by trade. That's how I came up. When I went to school, that is what I wanted to do. I started programming when I was, I don't know, 5th or 6th grade, something like that. I started taking computers apart. So that's kind of how I fell into this particular field. All right, next slide. So what is programming actually? It's like you hear about programmers, the hackers, you see them on TV. Programming is, ironically, I can't read a note of music, but I've heard it's like reading a note of music. There is an order to how you tell a computer what to do. And what we do in programming is we write what's known as code, and code forms the logic that tells the computer what to do. The interesting thing about logic is that it can be very tricky to learn. It can be very painful to learn. Some of you are multilingual. You know how hard it is to learn another language, right? Programming, like, here's the thing with learning another language, okay? Even if you don't know it perfectly, a lot of times you can be understood by using gestures or, hand signals or, pointing to things like whatever. If you make one, and you can still be understood, right? Like, even if it's not perfect. In programming, if it is not perfect, it will die and cause many tears, okay? So one of the things that I do here, I'm a programming instructor. So I teach the programming classes here, and I try and help students get over their fear of failure. That's one of the things that we try and instill in our graduates. But learning the art, the science, the skill of programming so that you can pick up many different programming languages. Because a lot of programmers, they know more than, they're not one-trick ponies. They know more than one language. And the thing is, once you learn one, it's a lot easier to learn other ones, okay? Next slide. All right, so there are many uses for programs. I'm not gonna go through each one of these things individually, but I can tell you, if you can code, you will have a job in IT, especially if you are, say, a network engineer and you need to move firewall rules from one firewall to another. You can do that manually if you like pain, or you can write a program that will do all of that shifting over for you. You can write scripts. There's all kinds of different things that you can do with that. And I'm gonna have Professor Hayden in a minute talk about a specialized part of that in the data science field. But lots of different uses for programming in code. All right, so what's in the day of a programmer? It's interesting, it's not all code. And as a matter of fact, I had very few days as a programmer where I was just doing coding. A lot of times there was a chunk of my day that was spent doing check-ins, meeting with stakeholders, meeting with a project manager. By the way, programmers are a project manager's worst nightmare, okay? Because we have what's known as programming time. So a good programmer, a good project manager knows to take any estimate that a developer gives them and double it immediately if they want to hit their deadlines, okay? But we are not well known for being timely, okay? We also spend a lot of time doing research. Sometimes there's a problem that we need to get some extra information for. So we're Googling the heck out of the internet, okay? Trying to mine that little nugget of information that's gonna get us over the problem that we have. And then we're testing those solutions. We're constantly taking our code, the code that we are writing, and testing it as we go to make sure that when we start to get to an integration phase and we start to get to a pre-production, let's move to a live implementation phase, we are testing that so not everything falls apart. Okay, we want to be doing what's known as unit testing, making sure our code is done. And we cover all of these types of skills in our programming core. So we talk about check-ins, we talk about testing, automated testing, discipline, like all of those things. But the thing that you need to know the most about coding is that you will never code anything if you only have like 15 or 20 minutes at a time. If you're getting distractions, right? If you're a full stack web developer like I am, so you've got PHP, HTML, JavaScript, CSS, and a whole bunch of APIs like in your head all at once. And then somebody comes and says, can you help me? It's the worst. It's the worst, okay? I'm saying that somewhat tongue in cheek because programmers are famous introverts, okay? But what you need to be a successful programmer is you have to understand that you need big chunks of time to get something done. Minimum of 4 hours. Put the headphones on, shut out the world. Like if you have to go find an office that is in a dark corner someplace to get something done, do it. But programmers know this, and good project managers know what it takes to get the most out of a program. It is allowing them to focus and spend hyper times of focus working on a project. Okay, next slide. All right, so is programming right for you? It's not on here. Do you like pain? Okay, you know, the corollary to that is, do you like being paid? Okay, because programming is a difficult discipline to learn, but you learn to solve a lot of problems. You can become an expert problem solver by learning to program. If you like creating things and testing them and seeing things that you build come to life, programming might be good for you. You have to be detail oriented. Okay, that is a skill that you can learn, and you learn it by going, oh crap, I forgot a parenthesis or a colon someplace and my program died. Okay, you have to be self-directed. You have to be very disciplined to be a programmer, and then you have to have this will to learn. Learn other programming languages, evolve. Like a lot of the programming languages that are out there, they're evolving, so you have to evolve with them. So you have to be constantly mindful of the landscape that is out there and up-leveling yourself continually. All right. Now, I'm going to have Professor Hayden talk about a specialized version of programming here that he is a specialist in here at the college.
All right. So yeah, the specialized area with using programming, I teach some of the programming classes also, but I also work in the wonderful world of databases. Back in the day, you know, programmers were always thought of as being cool, and really the cool kids that did stuff like Mr. Pets here was. And
Never a cool kid.
Okay, never a cool kid. Okay. Well, the database people were always
much cooler.
No, we were just kind of, we were the real introverts and stuff. So, but the fun thing is that data has exploded so much in the past 5-10 years that there's been an intersection. The programming, if you're interested in programming, but you like data, you're interested in the data analytics portion of it, it's a perfect field to be into. We use Python as our programming language of choice at Walsh. And so it's great for doing things, and it can be used in cybersecurity and data science. So we can prep that data, you know, we're looking and bringing in the raw data and really transforming it into something useful. So we can go to the next slide, please. And then here, yes, databases, yes, I'm not going to read the whole thing, but it can hold lots of data in here. But there's another language that some programmers don't really consider a true programming language called SQL, or structured query language, which is a very important language that's in demand and utilized, and it's a great thing to use. In our programming classes here, I know we use SQL within Python to connect to MySQL and MariaDB. So it's very important. And we're looking for things that are in the patterns in the data, insights in the data. So it's kind of a fun thing. So not as cool, quite as cool as he is, but, and I've known you for—
You're a better dresser though.
Just today, usually it's my usual uniform of polo and Dockers. Like. So anyway, I want to transition into Professor Kadavai, who is our statistics expert.
Good afternoon, everyone. I hope you had a wonderful day. What I'm going to do the next 5 minutes or so relates to understanding the curriculums that Walsh offers that focuses on data analytics. Then after that, I have a scenario in the life of a system analyst, a hypothetical situation with respect to the type of data analytics that a person in their normal working day would use as a system analyst to solve the problem. So Walsh College ITDS degree program that do have data analytics focus are the BSIT with the option of fast track to the MSDA program, which is the Master of Science in Data Analytics. Also, MSIT with concentration in cybersecurity and data science. These programs do have content in the context of giving the students data analytic skills that they need to solve organizational problems. organizational problems from many different views, but obviously I'll be talking about the aspect related to IT. When you look at the data analytics, decisions need to be made based on available data. And a lot of times we are limited to the type of data that we have available to us. And based on that, we need to figure out what kind of statistical analysis we would do. When it comes to IT field, in my mind, really, one can do a statistical approach of data analytics. And the other aspect of it is doing root cause analysis. Like for instance, if you have a failure in the operating system, you don't need to do statistical analysis. You need to do root cause analysis. You need to figure out what went wrong, what component resulted in the failure of the system. So towards that end, here's a scenario. Consider a scenario where a system analyst realizes that there has been data pattern changes in what he tracks every day with respect to the traffic data in terms of data pulls by the users, as well as a number of issues coming up with the system. So in aggregate, this IT worker really needs to understand, has the IT operating system user data pool traffic changed? That's the first question. And again, dare I say, since 2021, to give it a context, that requires data analytics. On the other hand, if based on data analytics, which I'll discuss the details of it in the next slide, if they find out, yeah, there are statistical evidence to suggest that now there is more data pool in the system. It's not just normal variation in users using the information, pulling information. It's really, there is a change. Then the question becomes, well, is current system capable of handling that volume of data that needs to be provided to the user? Is the computer hardware data storage adequate? If not, why not? Those are the type of questions that would require root cause analytics that we discussed earlier. Next slide, please. So the first question that was asked related to, has the IT operating system user data pool traffic changed since 2021? That requires statistically analyzing the data, comparing 2021 traffic to this year's traffic, 2022. And being a statistician, I had to throw that statement out there, saying, in this case, you would need to do 2 independent sample t-tests to figure out whether 2 population means are different, 2021 population versus 2022 population. The means in the context of average number of requests from the users. And if statistically we can prove that that data pattern has changed and there is indeed increase in request, then the next question is on the next slide, which says, well, if the root cause is that we have issues with increase in the volume, then we need to answer this question. Does the current computing system, whether it's the computer hardware data storage, whether it's computer software, data management system, or other aspect of the IT system that we have, can it meet the requirements in terms of the new demand that's needed? This would require doing what I call sizing of the system analysis in the context of root causing the problem. And as a part of the ITDS curriculum that we discussed, there are courses that specifically focuses on this type of analysis. I can name IT 501, system analysis, IT 530, SQL, the one that Professor Hayden was alluding to, are only 2 of the courses that provides you the skill sets that you would need to answer these type of questions. I acknowledge that I may have oversimplified a lot of the concepts, but that's really is something that in the context of IT workers do represents what I just described. Post your questions and I'll gladly, at the end of the session, I'll answer it. Next, I'd like to introduce Instructor Feruzi, who's going to talk about cybersecurity.
Hi, everybody. My name is Nicholas Feruzi, and I'm here to talk to you about the fun world of cybersecurity. So, cybersecurity encompasses pretty much all of IT, meaning networking guys, database guys, just name a particular set of area of IT, and you're going to have to know about it. So, what do we need to know a lot about? Of course, hardware, the networks, applications, risks, processes, planning, documentation for our systems. The list goes on and on and on. As I have highlighted there, you need to understand and predict human nature. But what do I mean by that? Well, as the next line states, not all attacks are done intentionally. For example, I'm on TDY and I have my laptop. Normally, my laptop stays geographically in one location. Now I'm trying to access my home network through a VPN, to connect to back home. So I get denied time and time again, and then I get a phone call asking, hey, is this a legitimate login? We have someone from this particular part of the country trying to access your account and from this machine. Is that you? Yes, so things like that happen. Next slide. Here's a fun one. So breaches aren't an if, they're a when. And anyone who thinks that they're not going to be breached is lying to themselves to make themselves feel better. So we have a process of course, you want to try to prevent breaches from happening, but you also want to prepare for a breach. What do I mean by that? We have your impact analysis, but you also have your tabletops. So at a tabletop, you discuss, okay, this potential denial of service attack can happen on our network or on our systems. What is our response to that? And the reason you do that at tabletops is so you can develop an instant response plan to that. Once you have an instant response plan, you'll know what systems could potentially be affected, and then you can have a recovery plan. Now, recovery plans are pretty deep in breadth. You have instant recovery, disaster recovery. A disaster could be a natural disaster like a hurricane or a flood or an act of God. Next slide. These are some skills you need. You have to be able to think critically. You have to understand documentation. You have to have attention to detail. You have to be able to focus on tasks. So problem solving and critical thinking on that list are the two biggest ones. So you have to be able to look at things differently you have to be able to look at them differently than you would otherwise if you're in another field. What do I mean by that? You'll get a group of people together that are trying to solve a particular problem, and everyone gets the same mindset going to try to solve the issue. Well, the best thing to do at that point is to step back and take the situation as a whole and say, we're trying to do things this way. The solution we came up with together is not working. What can we do differently to come up with a solution? So I'll touch back on what I said when I opened, where you have to really understand all the areas of IT to a degree. You have to be a jack of all trades, and they're master of none, as they say, but they're often better than a master of one. And more so what I mean by that is if I'm going to speak about networking with Professor Decroni, I have to know what I'm talking about. I can't just hand him, hey, I got this fancy looking number. What is this? He's going to look at me and ask how I got hired here. Next slide, please. So security incident event management. This is where we start looking at logs. This is where we look at our baseline of our systems or our network in some cases and compare it to anomalies that we detect. Now, a lot of you know what a SIEM or an SIEM software is. SolarWinds being the most infamous currently, and nail me to the cross for this if you want. It's arguably still the best. So what can you do with these logs? Well, you check for compliance issues. You check for if you have a breach, you can use this for a forensics case as well. Next slide. So a little bit of what I'm presently working if you are going to be in cybersecurity, you're going to have weeks, days, sometimes months that are pretty predictable and the same. Or you could get something like Log4j, which
It's
is
terrible.
fun. Yes,
Ugh.
yes, it's very fun.
Worst.
You're planning out your vacation, spending time with your family, and then you get a call from someone way up here asking, what is this Log4j thing and how affected are we? There goes your plans. So holiday's gone.
Month,
Holiday's gone.
2 months,
So-
quarter. It's
lot-
still going.
Yep, it's still going. The hits keep coming. So, of course, we do network monitoring. You try to determine how the event happened, and you even try to discuss details of how the event happened. From there, you can respond with your incident response plan, which hopefully you thought of something like this. If not, guess what emergency meeting you're having? Next slide, please. Speaking of logs, why don't we take a look at one?
Do you want to share yours? Or do you want me to bring it up?
If you could bring it up, that'd be great.
Okay, one moment. I'm going to reshare and bring up the log file. There we go. All right,
There we go.
Carrie, take it away.
All right. Now, let me preface this with a little bit of something. Normally, you'd have tools and applications that allow you to get through stuff like this pretty quickly. So you would not manually torture yourself with trying to sift through this. You do that to interns. That's why you have them. So, yes. Yep. Intern, you get to go through this entire log. Have fun.
Yeah.
So what we have here is a sample log.
Remember what I said about scripting?
Yes. Yep. Scripting will come in handy with this, but this is a sample log. This is not from a system that I currently work on during the day. That would be a huge security breach. So what we have here is we have an IP address from 173.234.31.186, and it's coming in at a high level port, and it's getting denied. So what do we do at this point? Do we just brush it off and forget about it? No, what we want to do is check our list of IPs we own that are known good. If it's on that list, then okay, we need to examine why this connection failed or why this user couldn't log in. But if it is not, then we have to investigate further. Then we have to get the team together and say, hey guys, we're getting hit with IP addresses from a certain part of the world. We need to respond to this. So that's when you get your networking guys involved, and you get your security analyst and even your even your information system security engineers involved, and you determine your response to that. So I said a lot there. What do I mean by response? You just don't go right to responding to a threat. There's rules of engagement. Like I can't just take one of these IP addresses and fire at it. That's not proper response. That could be a completely legitimate connection that could be made. Or I could be attacking, I don't know, maybe someone who works at GM from home and they accidentally tried logging into our SSH server. It could happen. You can't just fire away and forget. So there's a process to this. And I understand a lot of you watching this, documentation can be boring, policy is boring, procedure is boring. Well, you have those in place to protect you when you have a detailed plan of how you do things that you can fall back on. You're not just firing away every time and hoping you do it right. So I talked about networking, and you're gonna have Professor Dakruni talk about networking and how important it is.
Thank you. Hello, everyone. I'm Professor Dakruni. I teach here at Walsh. Mainly, I teach networking and cybersecurity. And in my day job, I work in networking. So that's what I'm here to talk about and shed some light about what networking is all about. When you work in networking, you work with the hardware, you work with software. And let me mention one thing also, what Professor Feruzi said, that you need to understand networking very well to do cybersecurity. Indeed, I'll say to all my students when I teach cybersecurity or networking, those two, networking and cybersecurity, they go in parallel. You need to understand networking in order to understand cybersecurity, because when you trace something like what he mentioned, for example, about the IP, so that IP, that's the networking node. Everything on the network has a number, like everybody now have a social security number. That's how we identify things on the network. So that's how we trace things. And we have nowadays, when we're working with the big infrastructure, we don't rely on like an eyes on the glass or somebody logging in. We rely on automation and tools, and those the tools will provide for us. So what the skills and attribute you need to do for as a networking engineer is you have to understand your network. You understand your architectures, where things connected from where to where. I worked with the Fortune 500 companies, like we operated in 34 countries, and we were managing about 40,000 nodes at once. So this is a big architecture. You need to think how they are connected hardware-wise. And then networking knowledge is huge. You have to understand what systems are running, what protocols, what's the type of hardware. All of those are part of the networking knowledge. And then that's things comes with the technical knowledge you have. In addition to that, problem solving. You have to put your thinking cap on, like the programmers, right? We have our own thinking hat as a network engineers. Is like when we have a problem in the field, we have like what we call, for example, iOS model. Like for example, we look at where the problem in the iOS model, or like where it is. Is it in the hardware? Is it in the software? Is it in the protocol? This is problem solving technique has to be there, and you have to be able to solve problem. The same thing in cybersecurity. Part of the job also, sometimes you have to design a network. You have to implement network in the field and to make it operational and secure at the same time. So sometimes you have to start from scratch, or sometimes you have to take over a network that already existed, and you have to make it also continue operation with it and make it better sometimes. So design also where to put things. And nowadays, as we said, cybersecurity and networking, they go parallel in parallel. So when you start designing from the scratch, you have to have always that security in your mind that has to be in place. Okay. And any IT job, any IT infrastructure, Professor Betts mentioned about time management. Time is a key, because you'll be juggling like different things at once, right? Working on this project, working on that project, have a hot potato problem right now I'm solving. So you need to be able to how to do time management pretty well. The same thing as we teach that in our students, like during the course, you have to manage your time where you do your homework, your labs, or your project on time. That's part of the management, different project priorities. Next slide, please. So here, what the network specialist will do. So I said, you have to know the architecture. I've been in the field for about 30 years, and mainly I work in networking. Wherever I go, I'll ask for a thing. What's the architecture of this network? How this network is being architected. So in case I have a problem, I need to look at it. Where is this connected? Like for example, here I have this router connected to this router. And then from this router, I have this LAN connected to it. And everything has to be in front of me. Sometimes a picture, explain 1,000 words, right? So I have to see everything, how it's connected in front of me. And then at the same time, I need to understand the hardware. So you need to understand the architecture, and you need to see how these devices are connected and talking to each other, and you're able to analyze and design out, see how the things are working and evaluate it. And also, this is part of the design. When you set up to design something, you need to know, okay, I have this side here and this side here. I'm going to put a router here and I put a router here, and I'm going to connect them through this link, and then I'm going to take them down to the LAN. So this is part of you need to understand architecture. Architecture in networking is very important to understand in order to do your job very well. Next slide, please. So what do I do as a network engineer, for example? What do I do on a daily basis? Okay. As I said before, I work in a bigger environment. We have about 40,000 nodes at once. There's no way for me to monitor all of those nodes at once, right? We have automation, we have tools, can see this for us. So the first thing I check, for example, what we call the health of the network. How's my networking doing today? Okay, what do I have outage? What do I have, like, for example, utilization? So that's part of my checking daily in the morning. So, and then also sometimes you'll be pulled up about everything you're doing to attend to hot problem, or like a problem in the field, or like a fiber cut, or like a router went down, everything. So you have to reroute traffic. So that's part of the attending to outages on a daily basis. And after that, we do a lot of like maintaining and making sure network operation is securely working in collaboration with different teams, because as I said, networking and cybersecurity, and also like, for example, all of those users connected to the network, they all have to work together in collaboration to make sure everything is connected together, because the server team need the network because they need us, because we need their servers to be connected, right? Cybersecurity, they want to understand what's going on with their IP, so they need networking folks. So that takes a lot of meeting, a lot of collaboration. And then over the last 15 or 20 years of my job, even though I was a network engineer, we can put slash to it and put security, because network and security goes together. At the same time, you have to manage projects simultaneously, and that's part of the job you do, and then make sure the network is upgraded properly, securely, and then make sure you'll be able to grow the network. So, of course, oversee network performance with security in mind is a key question here. It's a key thing. You need to understand security and networking at the same time. Next slide, please. This is like an example of no previous one, please. Okay. No, okay, next one. Okay, this one. So this is some of the tools. For example, one of the tools that I use, for example, for architecture, I use a Visio Microsoft. We have our whole architecture in a Visio Microsoft. By naming, for example, I click on a node or an IP, and we'll give you an architecture of that, how that node is connected. So we'll know sometimes when designing, when we are like troubleshooting the problem, we know what's affected by that. And also, if you work on a SOC or a NOC, SOC stands for Security Operations Center, or a NOC, Network Operations Center, you'll be like in a war room, you'll have the whole world in front of you. You'll see how everything is how connected. And if you have like a red alert, sometimes we have them here in this lab, you know what exactly where the location of that problem is, and you can take effect of it. And sometimes we go, for example, we have between two endpoints. We troubleshoot the problem. We go like one engineer would take one end, and another engineer would take the other end, and we're troubleshooting all the way to meet in the end to see where the problem in the middle. Next slide, please. As I said before, like you rely on automation, you rely on tools. So we use a lot of automation and tools to make our job easier. I'm telling you that for fact, I cannot do my job without my tools. Okay, and thanks to programmers and developers, they make our job easier. We develop some of those tools are you can buy like from third party, and they can develop it for you. I mean, they can embed it for you in your environment. Or sometimes if you have a good programmers, they can tell them what you need. And we did that at the Bank of America when I was working there. We told them, this is our network, this is our architecture. We need to design a tool that monitor everything on the network. I mean, to the detail of like sometimes if the temperature in the data center, these tools will tell us like there's a humidity factor in the data center. So in addition to utilization and outage and stuff like that. So tools and automation is a key here, and we rely on them to do our job. Next, please. So in summary, what we do, we design the network, we configure it, we manage it, and we operate it. So make sure operation day-to-day business is the key here. And then this is how we keep the world connected, and that's how we communicate nowadays. And I don't think we can live our world we live right now without the network. Okay. So at the end, we will be taking some questions. If you guys need to know more about networking, I'll be available. Thank you.
Awesome. All right, thanks everyone. Hopefully that was informative. There's a lot of stuff that you can do in this field. I have an awesome role, which is I get to manage all these folks, right? And set goals, do different projects. It is really exciting. I love being in IT. One of the things that I like being in IT is working with really amazing, smart people. And when we bring students into Walsh, they're not always confident with different skills and stuff, but our goal here is to build your confidence so that you get out there and rock it, okay? We want you to be the people who everybody wants to work with because you know it, you've done it, and you have practiced it, and you have a network of people that you come out of Walsh working with that you want to work with for a very, very long time. I have known Professor Hayden for almost 30 years. I have known Professor Richard for almost 20 years. I have known Nick for 5. I'm sorry. And we build these networks of people, and the people who are on my team, I love working with those individuals. And we solve big problems, and we work very, very well together. So that is in a nutshell what some of these careers look like. We'd be happy to take any questions that you have, and then we will turn you over to our admissions advisors and career services teams. Do any of you have any questions on anything that you have heard today?
No one's gonna ask about how to hack someone's Facebook. No one. All right.
All right. Well, we are all here to answer any questions. If you happen to reach out to an admissions person or advisor, they can put you in touch with one of us who we're glad to talk about our programs and our experience. What you should hear here, Walsh grad, you're a Walsh grad, I'm a Walsh grad.
Me
And
too.
yep, Terry is a Walsh grad. And lots and lots of years of experience. The stuff that you would learn from Professor Daccaroni about network scalability, you're gonna have a hard time finding somebody who has his kind of experience. Working with Javad Kadabai, he knows statistics like no other person that I have ever seen. Statistics and data analysis. He knows the stuff. Professor Hayden, he is a data whiz, knows the stuff inside out, and is able to put together a lot of things very, very quickly. We have worked with, we have had consulting engagements with Automation Alley, some big people in the area helping them solve some of the biggest problems facing their organization. So that is what we had to say. If you have any questions, again, we're here for you, but at this point, we'll turn it over to the folks on the tour.
Very good. Well, thank you everybody for attending today. My name is Gabriel. I'm one of the admissions advisors here. Some of you I know, some of you I've helped register for classes, so it's very good to see everybody here. I hope you thoroughly enjoyed today. I first want to thank our faculty members for coming out and doing this. This is very important to us and really truly a great resource for you as students. So for anybody that is a current student, if you're not interested in the admissions process again right now, you can head out and work with Kathy. She will start the campus tour for you. And then for those of you that are on the Zoom call, just real quickly, we'll kind of cover some of our admission requirements. So at the undergraduate level for the BSIT program or a Bachelor's of Science in Information Technology, with that program, we are looking for at least 60 semester credit hours completed with a grade of a C or better or a completed associate's degree, and then a GPA above a 2.75. So for us, we can work with each of you to go through your transcripts. We can follow up after this event today, and we'll go ahead, take a look at your transcripts, and we can evaluate them for transfer equivalencies, as well as let you know what you still have to take. Oppositely, at the master's level, for our Master's of Science in Information Technology, the Master of Science in Information Technology Leadership, the Master of Science in Data Analytics, and our dual programs, as well as the certificate programs, we are looking for a completed bachelor's degree and again, a GPA of above a 2.75. For all students, whether undergrad or graduate, we can start your admission with unofficial copies of your transcript, but by the end of your first semester, we will need those official copies. Each of our different advisors can help you do so. I am the admission advisor for the ITDS department, so most of you will primarily work with me throughout your time here in your first semester, and then we'll hand you over and start the transition to working with academic advising. So again, my name is Gabriel. Thank you very much for coming to this event. We hope that you enjoyed it and got something useful and beneficial out of this, and I will turn it over to Stephanie in academics.